Well, hello again, everyone. Mr. Reeves back with you today. And in this video, we are talking about the theoretical probability of compound events. So just a quick review. We are in our study of probability. And earlier we talked about the probability of a single event or simple probability where we did one thing like roll a die or toss a coin or spin a spinner. We just had one event and we looked at the outcomes and we looked at what is the chance of us getting what we want out of all of the possible outcomes. So those were single events. That was simple probability. Now we're making things a little bit more complicated. So hopefully you've taken the time already to do some preparation and watched the other material and taken notes on sample spaces and the counting principle. And now we're moving on to actually finding some probabilities of compound events. All right, so I'm going to go ahead and work through some IXL problems to help us learn. One of the things that we have to talk about when we deal with compound events is, are these events independent or dependent? Independent events means what happened in the first event does not affect what happens in the second event. Or whatever happened in the first event does not change the number of outcomes that are possible in the second event. That is when it's independent. Dependent means that what happened the first time does affect what happens the second time. So a common example for independence would be spinning a spinner. When you spin a spinner the first time, you can get a result, and when you spin the spinner the second time, what happened the first time does not affect what happened the second time. But an example of a dependent event would be like pulling a marble out of a bag of marbles. So if you pull a marble out of a bag of marbles and then you don't put that marble back, then what happened the first time affects what happens the second time, because when you go to grab a marble for the second time, that marble that you pulled out the first time is no longer in there. So there's less marbles to choose from, and the one you already have is not one of your choices. All right, so we're going to start in IXL on the skill identifying independent and dependent events. We'll work through some of these examples, and then we'll actually do some probability problems. Here it goes. It says the students in a science class are told they should pick a dinosaur about which to write a report. They are also informed that it does not matter whether anyone else has picked the same dinosaur. Sally and her friend Nora submit their choices. Are they dependent or independent? Well, the key words are here is it says it does not matter whether anyone else has picked the same dinosaur. So that means since their choices don't affect other people's choices, we're going to say these are independent events. A babysitter tells two brothers that she will get each one's favorite candy when she goes to the grocery store. The older brother whispers his preference in the babysitter's ear, and then the younger brother does the same. All right, so are these independent or dependent? Well, since each of them could choose the same thing or choose differently, and their choices don't affect the other, we're going to go with independent. All right, here we go. Gabrielle spins the spinner twice. Well, this was the example I gave. When you spin that spinner the first time, it can land anywhere. And when you spin that spinner the second time, it can also land anywhere. We're going to go with independent. All right, so Nancy picks a marble at random, puts it back, and then picks another marble at random. Now, earlier when I talked about marbles, I said that it was dependent, but the key there was I said we were not putting that marble back, but here it says we're putting it back. So we start with a green, orange, and a pink marble the first time, and then our second time, because whatever we got, we put it back, we have the same three choices. That is going to be independent. All right, so hopefully you got an idea of independent versus dependent. Again, dependent means that the second outcome is affected by what happened in the first event, and independent means whatever happened first has no effect on what happens second. All right, let's go ahead and go now to probability of independent and dependent events. So previously we were just deciding are they independent or dependent. Now we want to know the probability. Now again, just a reminder, quick reminder of what probability is. So if we look at probability, let's see if we can actually spell it right here. Probability. I'm still not spelling it right. All right, it's right there, Mr. Reeves. Probability. Probability. Why is this so hard? I need another glass of coffee. Prob. Bill, there we go. The key is getting two B's here. The probability. So probability is the number of favorable outcomes over the total number of outcomes. Right? In other words, what we want to get over the total things we could get. And in simple probability, we just have one event, but in compound probability, we're now looking at two or more events. All right, so let's take a look then at this first problem. It says you spin the spinner twice. All right, so previously we talked about the spinner and how it's independent, right? Whatever I get the first time does not affect what I get the second time. So what is the probability of landing on a 2 and then landing on a 3? All right, so the probability of landing on a 2 is 1 out of 3, right? And the probability of landing on a 3, because whatever happened the first time doesn't affect the second time, is also a 1 out of 3. So if we were looking at simple probabilities, the simple probability for each event is 1 out of 3. But then what happens when we want both of them to happen? We want to land on a 2 and then land on a 3. So should that be an easier thing to happen than if we did them separately, or harder? Is it harder to get both things to happen? And the answer is yes, it's harder to get both things to happen. So let's quickly look at the possible outcomes and then see if we can come up with the answer to this question, right? So I'm going to put S1 for spin 1, and then I'm going to put S2 for spin 2. So if we spin a 1 the first time, what could we get the second time? We could get a 1 again, right? Or if we spin a 1 the first time, we could get a 2. Or if we spin a 1 the first time, we could get a 3, right? Well, what about if we didn't spin a 1 the first time? What about if we spun a 2? Then we could get a 1, or we could get a 2, or we could get a 3. And finally, let's get this out of the way here. If we spun a 3 the first time, we could get a 1 the second time, we could get a 2 the second time, or we can get a 3 the second time. So do you see how this represents all of the possible outcomes? This is all the times we spun a 1 the first time. This is all the times we spun a 2 the first time. This is all the time we spun a 3 the first time. And then these are the possible outcomes, 1, 2, 3 each time. Well, if we count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there are 9 total outcomes that are possible. Remember, this is called our sample space. This is what we worked on in our previous lesson, coming up with all these choices. Well, what did we want? We wanted a 2 and then a 3. So do you see right here? That is what we were looking for. Right here, this is what we were looking for. We wanted a 2 and then a 3. So how many favorable outcomes were there? There's one favorable outcome, right? And how many total outcomes were there? There were 9. So the probability would be 1 out of 9, right? Now let me ask you a question. Let's go back. We had 1/3 and 1/3. We know now that the answer is 1/9. How do you get 1/9 from 1/3 and 1/3? Do you get it by adding? Well, if you add 1/3 to 1/3, you get 2/3. And that would not be what we're looking for. What about if we multiply? 1 times 1 is 1. 3 times 3 is 9. Wow, so if we multiply the probability of each independent event, we will get the probability we will looking for. So again, this is an important idea. Multiply the independent probability. I spelled it wrong again. Probability of each event. Multiply the probability of each event to get the probability of the compound event. And that, ladies and gentlemen, is what we are trying to find. We are trying to find the probability of the compound event, and we're going to get that by multiplying, not by adding, not by subtracting, not by dividing. We're going to multiply those independent probabilities. All right? So the answer we're looking for is 1 divided by 9. Let's go ahead and put that into iExcel, and we'll see that it is correct. Okay, you pick a card at random without putting the first card back. You pick a second card at random. So if this were a question in the previous set of problems we were doing, and I said, is this independent or dependent? I would hope that you would answer that it's dependent because we are not putting the card back. So when we first start, we have 3 options, right? We have a 7, an 8, or a 9 that we can choose from. But after that, we're only going to have 2 options. If we had picked the 7, only 8 and 9 would remain. If we had picked the 9, only 7 and 8 would remain. And if we had picked the 8, then only the 7 and the 9 would remain. Is that what I said? Oh, well, you get the idea, right? 3 possibilities the first time, 2 possibilities the second time. All right, so here we go. So it says, what is the probability of picking an 8 and then picking a 7? All right, so if we picked an 8, the first time, let me just ask you, what is the probability? And by the way, I hope you've seen this symbol, the probability. This means right here, the probability. Hey, I spelled it right the first time. Of choosing an 8. All right, so the probability of choosing an 8 is what? 1, because that's our favorable outcome, right? That's our favorable outcome. Out of how many total outcomes do we have? We have 3. So the probability of choosing that 8 is 1 out of 3. All right, so we picked the 8. It is now gone, right? So what are our remaining choices? Well, now there are 2 left, right? So if we pick an 8, so again, if we're going to call this P1 for pick 1, right? And P2 for pick 2, and we're saying our pick 1, we're going to go ahead and say that was an 8, then pick 2 could be a 7, or pick 2 could be a 9, right? So we have only 2 possible outcomes, right? And out of those 2 outcomes, which is the one we wanted? An 8 and then a 7, right? So the probability of our second event here is 1/2, right? So the probability of choosing, now again, I'm going to put the probability of a 7 because now we're trying to choose that 7, right, is 1/2. All right, so we have the probability of an 8 the first time was 1/3, and the probability of a 7 the second time, which went down to 1/2 because this was a dependent event. All right, so there's our probabilities separately. And what did we say we want to do with those probabilities? Do we want to add them? I don't think so. Do we want to subtract or divide them? No way, Jose. We want to multiply, and we get 1/3 times 1/2, which is 1/6. So we have a 1 out of 6 probability when we have these 3 cards that the first one will be an 8 and the second one will be a 7. 1 out of 6. Let's see how we did. Keep it up. All right, what is the probability of rolling a 5 and then rolling a 5? So let me ask you a question. Independent or dependent first? If I roll the die and then I roll the die again, does it really matter what I got the first time? All right, and the answer is no. You might think, well, I got a 5, so the next time I have less of a chance of getting a 5. No, you have an equal chance of getting a 5. A probability of getting a 5 the first time is 1 out of 6. The probability of getting a 5 the second time is also 1 out of 6. And we're not going to add, we are not going to subtract, we are not going to divide, we are going to multiply. And 1/6 times 1/6, ladies and gentlemen, boys and girls, is 1/36. All right, to get the idea? All right, so again, I'll do one more example here. We have one of these card decks again. This time we have 4 of them. All right, and we are not going to put the card back. We want to pick a 4 and then pick a 5. So let me ask you, on our first event, what is the probability of picking this 4? Well, how many 4s are there? There's 1 4. How many total cards are there? There are 4 of them. So the probability of picking that 4 is 1 out of 4. But then, ladies and gentlemen, that 4 is gone. It is not there anymore. All right, because we didn't put it back. Now I'm trying to pick a 5, right? So now I'm looking to pick a 5, but there's not 4 cards. Now there's only how many? 1, 2, 3. So the probability of our first event that we wanted was 1 out of 4. The probability of our second event, again because it was a dependent event, is 1 out of 3. And you, of course, by now are the expert knowing that we are not going to add, we're not going to subtract, we are not going to divide, we are going to multiply these probabilities, and we get 1/12. So we have only a 1 out of 12 probability of getting those results. All right? Okay, finally, let's go ahead and look at some more examples. Probability of compound events is going to be very similar to what we were just doing. All right, what is the probability of both coins landing on tails? All right, so I have a coin here and a coin here. They are completely independent of each other. Whatever happens to this coin has no effect as to what happens to that coin. So the probability of it landing on tails on the first coin, right? So the probability of tails on the first coin is 1 out of 2. And the probability of tails on the second coin is 1 out of 2. And what are we going to do? We're not going to add, we're not going to subtract, we're not going to divide, we're going to multiply 1 out of 2 times 1 out of 2. And that's going to give us 1 out of 4. If we toss these coins 4 times, 1 out of the 4 times should have given us tails and then tails, right? All right, what is the probability of flipping tails and then rolling a 5? Okay, so what is the probability of getting tails on a coin? Again, 2 sides. One of them is a tail, so 1 out of 2. What is the probability of rolling a 5? Well, how many faces does this die have? it has 6, right? Each of those faces is numbered either 1, 2, 3, 4, 5, or 6. How many of those faces has a 5 on it? Well, only one of them does, right? Only this one right here is the 5. There's the 5, there's the tail. So isn't that nice, right? Except shouldn't the 5 be on top if we're rolling it? Anyways, that's neither here nor there. We have 1 out of 2 chance of getting a tail. We have 1 out of 6 chance of rolling a 5. We are going to multiply because we don't subtract or add or divide these probabilities, and we get 1 over 12. So again, we have a 1 out of 12 chance, which is not a very likely chance, right? It is not likely that that's going to occur. All right? Okay, well, it's just going to be doing very much the same thing over and over again. Remember, you want to take a look at these events and determine, are they independent or dependent? If they are dependent, that's going to reduce the number of possible outcomes on that second event. And then whatever probabilities you get for each event separately, you're not going to add, you're not going to subtract, you're not going to divide, you're going to multiply those probabilities. And that will give you the probability of a compound event. Thanks for watching, everybody. I hope this helped you. Have a great day.